Alright, so Kaz would like to hear about the directional derivative problem on the test. So we've got a function f of x and y, right? That's what? E to the
y squared minus x squared.
Okay, so I've got e to the y squared minus x squared. And I want to do at what?
Negative 1.
1, negative 1. And in
the v direct.
Or maybe towards.
Towards the vector. Negative 1, 2.
Negative 1, 2. Okay, so if I'm supposed to find a directional derivative, what should I start with?
The 2 points?
Yeah, do the f. I do f of x and f of y.
Yeah, I'd start with the partial.
Yeah.
Right, you're asked to find some directional derivative. You can probably get most of the points by just finding the derivatives. So fx at x of x and y and fy of x and y are what? Okay, so I'm doing a derivative of e to the stuff, right? So I get e to the stuff times the derivative of the stuff. Okay, so I got minus 2x e to the stuff. And for fy, I'm going to get
Parentheses e to the y squared minus x squared times 2y. So pretty much the same.
perfect. Yeah, pretty much the same thing, right? Except that x's and y's have exchanged spots, and yeah, there's a minus sign on the fx, right? Okay, so I found these. Then what?
Find a unit vector.
Okay,
Evaluate.
so I need a unit vector, and I also need to
Evaluate them at that point.
I also need them at the point, right? So either one of those, you're going to do both eventually. So fx at 1, negative 1 is
Negative 2
negative 2. E to the 0
is 1, so negative 2 is your answer.
and fy at 1, negative 1.
Same thing.
2.
And then, yeah, negative 2 is the answer.
So fy, right? And I'm putting negative 1 in for y and 1 in for x. So I do, in fact, get negative 2. You could have noted this in shorter hand, right? By writing the gradient of f, right, is made of these two pieces, and the gradient of f evaluated at 1, negative 1 is these two pieces, right? So maybe that would have been a little shorter hand, but you'd get the same thing. Then Donald says we need a unit vector, right? Why do I need a unit vector?
It's part of the definition of the...
It's part of the definition, or maybe if you think to yourself about it, you want towards this vector, right? Or in the direction of. Do I care how long this vector is? No, so I want to kind of remove the length information from it. Okay? So to remove the length information, you divide by the length, then it's length 1, and everything's kind of copacetic. Cool? Alright, so what's your unit vector pointed at v? Have I ever used this notation?
No.
No.
Well,
What would you write instead?
vector z over the magnitude.
Yeah.
Oh, okay, yeah.
That's all
So
right.
you just do this thing without labeling?
Yeah.
That's fine. Okay, so here's your vector v, and you're going to divide by,
The square root of 1 squared plus 2 squared.
perfect, square root of 5. Okay, so out of this you get a vector that looks like negative 1 over root 5, 2 over root 5. Okay, then what do you do with that?
Rationalize.
No,
Or you,
forget that.
you evaluate at the f of x and f of y. So
Well, first.
you
Yeah, I want to dot that with the gradient vector evaluated at my point.
yeah.
So I want to calculate negative 2, negative 2 dot product with this thing. Okay, and what do I get?
You get
2 minus.
well, 2 times 2 is 4, not 1. So you get
Okay, so you get 2 over the square root of 5 minus 4 over the square root of 5. Because 2 times 2 is 4, not 1.
Yeah, I crossed it out. I don't know why.
I think Sarah wins most embarrassing arithmetic mistake.
Yeah.
But this is not a big deal.
That's what.
What'd she do?
I put 2, instead of like doing 2 times 2, I just crossed them both out. And cause
Yeah, right? One was on top of
I
a
was- I
fraction, the other
divided
one was
them.
in front.
I just
Cancel?
divided them instead of turning them.
Big deal?
No, that's the point.
Not really, but maybe check your arithmetic before you launch rockets, right? So, out of this whole business, we get -2 over the square root of 5. Perfect. Questions, thanks? So, in the end here, right, we ended up doing the gradient of f dotted with a unit vector, right? That's our directional derivative.